Well, the title of our presentation, Simplifying Complex Coal, I got a question mark there because it's a tall order. And we'll see how we do today on simplifying complex coal. What I'm going to talk about is seam characterization and compositing. We're not trying to be comprehensive in our presentation here today, but we want to focus a little bit on what we're doing with MS Torque and the compositing routines that connect to MS Torque. And Jesse's going to talk a little bit about how we use cuts and cut development with MSIP. Okay, so to start off, a little bit of nomenclature on complex coal, with apologies to you geologists. But I just want to introduce a couple of terms and concepts for you so you understand what we're doing with our characterization and compositing routines. Working from right to left, we're looking at the drill hole information that we get on a complex coal information in conceptual format at drill hole level details. So shown in black are what would be coal intersections at let's say order of size would be decimeters, and parting information or rock. So that's how a geologist sees the drill hole information. And what we're trying to do in simplifying complex coal is we're trying to only look at what we need to look at when we need to look at it. So in the middle unit, under mineable units, the way a miner or an operator would see a coal intersection is not all the layers, shale, coal, shale, coal, shale, coal at decimeter intervals. What he's going to see is, okay, I'm supposed to dig from this point to this point, from one elevation to another elevation, and all of those are going to go in one pass, and they're all going to go to one destination. Some of it may be coal, some of it may be waste. So what we want to do is characterize and composite the drill hole detail into a level that makes sense from a mining point of view. And while doing that, we want to preserve the integrity of the data by keeping track of the true thickness of the intersects and also the nature of the material, whether it's coal or rock. Okay, showing on the left side, ultimately, from a planning point of view, when you're looking at planning at a bench scale level, you don't even need the mineable units known. What you need to know is, like from a spatial perspective, what you need to know is that your volumes are remaining accurate. So I can't remember if I'm talking about accuracy or precision here from the talk this morning, but we don't need to know spatially exactly from a long-range planning perspective where the coal is across the bench, only that the coal is going to be on the bench. So there's a simplification by function. Just to give you an idea of what order of magnitude we're talking about, in a project we worked on recently at the split level, at the detail level in the geologic coverage in our MS Torque database, we had roughly 150 unique coal codes. Those would have been birthed from approximately 60 plies, parent plies. Within a ply you may have coal, waste, and then those plies would have been a part of about a dozen or so depositional packages over the course of the project. So by doing this characterization and compositing to functional units, we can simplify the amount of work required to plan the project. Okay, so what we're trying to do is preserve data integrity, the thickness and the characteristic of the intersection in more and more general terms, but not losing accuracy. By characterization, I mean we're going to call the interval coal or rock, and we're going to call it thin or thick. And by thin or thick, I mean relative to mining parameters that are established by the client. Thin or thick usually means, is it mineable? Can it be separated? We're talking about deposits that have stratification, like I say, partings in the decimeter or less thickness. And some operators are saying they're able to remove partings down to a half meter, even 30 centimeters of thickness in order to mine the coal in a clean fashion, rather than mine the coal and parting at the same time. Not every operator is going to have the same standards, and not all standards are applicable depending on how steep the coal is dipping in the project. So characterization, is it coal or is it rock, is it thin or is it thick? Consolidation, now we look at only the coal intervals are coded at this stage in our drill hole coverage in MS Torque. So what we're looking at now is we analyze the sequence of the intercepts. And the sequence of the intercepts will tell us whether or not, if we combine 2 or 3 or 4 units, coal, shale, does the resulting composite or consolidated data remain economic, and does it become thick enough to be mined by the equipment going to do the mining? So consolidation. We use, I'll talk a little bit more about the procedures we use to do that in a minute. Once the coding has been done in the consolidation step, then we composite honoring those codes. And in the process we're using right now, we're actually compositing and then exporting that and compositing composites in order to meet the goals that we're trying to achieve. We'll talk a little bit about that in a moment. Okay, so characterization, right, I mentioned thick, thin, coal, thick, thin, rock. Now what we're doing is moving this data into MS Torque database and into sample attributes of their own. So each of these would have its own attribute, and then they would be twinned. Would each of these materials be mined as waste or mined as coal? Just because a unit in the model is, or in a drill hole is identified as coal doesn't necessarily mean it's going to end up in the plant. Some coal's too thin to recover, and conversely, just because it's labeled as rock doesn't mean it's going to go to the dump. Some rock is too thin, must be mined with coal in order to recover that coal, and therefore rock ends up going to the plant as well. By doing this binning or this characterization, we're able to keep track of how much of these types of units are being moved from an ultimate waste designation versus a coal designation. And in so doing, we can analyze mining assumptions, assuming you can mine a half-meter parting, or assuming you can mine a third of a meter parting. We can analyze what that might do to the distribution of feed versus waste units in the composite file. That helps operators know how complicated the deposit is they're working with, helps them make economic decisions about equipment and operations. Oh, yeah. One further characterization that may be appropriate. I mentioned 160 unique seam splits codes on the project we're working with. Of course, not all of these are going to be modeled, especially not early in a project's lifespan. So non-enumerated coal are those coals that are identified as coal but haven't been given a valid seam code for the project we're going to work on. Consolidation of intervals. This is where we're analyzing the sequence of coal, waste in the depositional sequence identified in the drill hole. We're running procedures such as PDH tag, PDH min, PDH seam below, and effectively what they're doing is identifying and coding partings that are too thin to be mined, but if mined with the coal above and below it, don't reduce the quality and the economics of the package to a point where it becomes uneconomic. If that's the case, then the waste interval will be given the code of the coal below it. Okay, so what we're trying to do in consolidation is just package up the coal waste units in a way that the operators would see in the way they're going to operate in the field. Compositing and compositing composites. Okay. So I've talked about this first slide, the detailed lithology, interval thicknesses and quality are on a interval by interval basis or kept in MS coverage. And then we bin them according to thickness and lithology type. Then we apply mining rules to consolidate the data and code the waste part or the waste intervals that must be mined with coal, and code the coal intervals that will be mined with waste in order to create a composite code that we can composite to, a code that we can honor and do in our compositing. So the first composite, we composite the data, so there might be 10 intervals, coal, waste, and so on, that we composite to create what is a single mineable length. So we're doing fixed length compositing. And by definition, there are not going to be any separable partings in this unit, so it'll begin and end with coal. There may be inseparable partings and a series of coal splits within the unit, but it only contains material that will end up going to the plant. In this way, we are able to calculate or composite also the internal quality, the in-situ quality of that series. And then what we do is export that composite data and re-import it we export the composite data, re-import it as a new assay or interval coverage. And the advantage of doing this, what we're trying to do is now we want to keep track. This is the mineable unit in the whole. When we re-import it into MineSight as a new assay, the waste material that's between the composites now is uncoded. It's not coded, so we can re-tag again. When we tag again the second time, what we're doing is tagging separable partings between the mineable units. And once the tagging is done, we're able to composite a second time. Compositing the second time creates the planning unit, and the mineable lengths and the quality of the coal in that planning unit is preserved. Okay, I'm going to talk about this a little bit further as to how we do it. In the third step, we export the composites, we re-import them as intervals, and then we tag one more time, and what we're tagging at this time is now the interburden. So this might be a 20 meter, 10, 15, 20, 30, 40 meter thickness between the planning units, and that interval is going to get coded with the same code as the planning unit. We also add missing seams at that point, and missing seams are introduced. That's if there's an enumerated seam that's not present in a drill hole that should be present, a seam thickness of 0 is applied, so that when we run our modeling, volume modeling by seam codes, that thickness will be treated at 0 at that point. So if there's codes on either side of it that have thickness, the coal in that unit will pinch out towards that center hole. Okay, mineable unit composite. We talked about this some. The inputs here is the interval coverage in the MS torque coverage, and also the quality units by lithology. So we're typically looking at ash, SG, and FSI and yield for each of the individual plies within that mineable unit. What's output is the quality attributes for that mineable unit and no separable partings. The way we do it is the binned interval lengths are composited honoring that seam code using a weighting by length and inverse length. So let's see, yeah. So by doing it this way, what happens is total weight ends up being a count of the intervals examined. And once we have the count of the intervals examined, we step out of torque into MS compass and convert those bin averages back to lengths. So bin average times total weight equals total bin length. Now this step is important in the next piece. It's just where we're compiling the mineable units into a planning unit composite. The attributes, now we're bringing one record in per mineable unit, and we're looking at the separable partings between the mineable units. They end up with the code of the seam below, and then what we're included in the final planning unit composite is the number of mineable units in that composite and the quality attributes for the feed in the composite. True thickness and seam dip for the units in that planning composite can be attributed by the true thickness and seam dip tool. Right. Okay, so by definition, a mineable unit's got a count of 1. But sometimes we've got more than one mineable unit in a planning unit. So when we import the composite data from the first round of compositing and then recomposite, we're actually counting the seams that are in that planning unit. And the whole purpose of doing this is to get an accurate way of estimating seam loss and dilution. I'll talk a little bit about that on an upcoming slide here. Oh, I thought I was going to talk about it. We've got a couple hidden here. Okay, maybe I won't. Okay, again, we're weighting by length and inverse length. That's what's counting our mineable units. Right, and then the number of mineable units in the planning composite is the total weight minus 1 divided by 2 plus 1. Number of partings is just mineable units minus 1. A mineable unit always starts with coal, always ends with coal. Okay, final step. The planning unit coverage is exported and re-imported as an interval coverage again, and then our tagging procedures are run to tag the interburden as the waste between the planning units. It's coded with the appropriate seam code and then binned to an I-thick item in the coverage. Missing seams are added at 0 thickness, and bin lengths and qualities are recomposited. So finally, what we've got in the unit in the final model unit composite, we've preserved the individual lithology and quality attributes. We know how much coal is in the composite. We know how much of that is mineable. We know how much parting is in the composite. We know how much of that is non-removable. We know how many partings there are in the composite, and we know the thickness of the partings in the composite. So all the requirements for doing detailed planning work have now been boiled down to this one final planning or model composite. Okay, we've got a couple of slides that were hidden, so I guess Jesse's going to pick it up here. But maybe what I'll do to introduce is the whole reason that we're doing the out and in with the compositing is to be able to count the mineable plies in a composite. And the reason that's important, counting those mineable plies, we know that there may be 5 meters of parting in a composite, but what we need to know is how many times does a dozer or a backhoe have to pull that material off a coal seam in order to properly estimate what loss and dilution will be in the field. So that's the reason for the out and the in. Loss and dilution on a given coal seam can vary from 2-3% on a 3-meter coal seam up as high as 40-50%, of course, when you get down to the very thin seams. Okay. And ultimately, if you're mining to preserve coal recovery, what's going to happen if you take extra dilution is yields in the plant will go down, and that's what we're trying to identify, is how far down will the yields go. Okay. Jess, you want to take it from here?
So what I'm going to be talking about is cut development and the way that you want to use that from a long range to a short range kind of planning, and why that's important, and why it's important to have the right information in our planning tool. So what we have generally, the spiral of kind of information on a long range plan, you have ore and waste, or coal and waste, and as you get further and further into your planning cycle, there's some of these information becomes more dependent. You don't just want truck and shovel hours, you want to know where it's going, and you want to track quality and yield and that type of information, as well as some of these other things which I'll show in a little bit of estimated equipment hours for your auxiliary equipment. This could be for a budgeting purpose or for a scheduling bottleneck purpose. Both of these can come into effect and can have an impact on your schedule and determine whether it's feasible or unfeasible. So in here, we're just kind of showing, apologies for that side of the room, I'll point to this one over here, but we're just showing kind of what's happening on a bench level. We have multiple amounts of activities, and on a long-range planning schedule in a strategic planner, you're just looking at coal and waste. I'm just going to use those words for the rest of this presentation. But when you're looking at in a smaller level of detail, the order of things matters. So where you first access the bench is not necessarily going to be where your final access is, which is over there. So your final access ramp ends up being over there, but because of the sequential nature of how you have to mine it, and that it matters that this waste gets cleaned off before this can happen, and that has to happen before that can happen. All the mining of these complex coal arrangements has to happen in sequence. So you can't just go and mine this waste and then that waste and pick that coal and that coal. You have to mine this in an order, and not only in order, like a lot of these activities cannot happen simultaneously in the same area. So the shovel has to clean off a bunch of waste, the dozers have to push down waste, the backhoes have to clean it, and you need a certain amount of separation between those activities, or you start getting trucks interfering with each other and stuff like that. And this is kind of a little bit of a zoom out, as you can start to see what can happen if you don't schedule on a short range process. If you don't schedule it right, what happens when this shovel is mined out all of this waste here and this coal hasn't been moved, or that coal hasn't been moved? Where does he go? He's got no waste to mine. So you want to make sure that you are tracking these in the right order, and not only just the shovel and truck hours, but how many backhoe hours do we need to pull down that coal and move it? How many dozer hours do we need? Do we need a dozer, or can we mine that with a shovel? All these questions become kind of important. And this is just showing If you're just looking at a cut, you can separate out your heading waste. So you have this type of waste and that type of waste and that ore or coal seams. But even in one type of cut, you have a high productivity waste, which would be all this blue colored waste, and you have what we're calling like a mid productivity waste that depending on the geometry of the coal seam, that has to be either side pushed down with the dozer, or if the coal seam's flat enough, it can be straight pushed down to the bottom. But the geometry of the coal seam and the thickness of the coal seam will affect of what type of recovery of the waste you can do. And even if you go to an extreme example, even thin waste headings may have to be pulled down with a backhoe. So you have multiple different types of scenarios that can happen, and it becomes more complicated than just a volume times a productivity, calculating your hours, and when you get your coal release. So how do we want to start tracking all this information? How can we even bring that in? How do we make sure we have this information in our schedule to use so that we develop not only an optimized schedule, but a feasible schedule? If we develop a schedule where our shovels run out of waste and has no more to dig before the backhoes can move the coal, it's not a feasible schedule. But if we can get that in, we want to develop an optimum schedule and not just calculate our dozer and backhoe hours on the back end of the schedule. We want to have that at our fingertips to use for planning purposes. So what we do is we take this one bench and we divide it up into multiple areas, and each of these areas have different attributes assigned to them. We have a first access cut, we have a construction cut, which would be our final access. That's a ramp down, built to ramp grade, which a large shovel will be digging at a different productivity. We have our, generic kind of boring waste, a shovel and digs away, high productivity. We have, a minimum mining cut, which would establish some width to allow the next sequence to happen. And in here, we have all our complex activity happening. So we can subdivide up into different areas, but inside these areas, such as this one right here or this one, we have multiple activities happening as well. So we need to further subdivide those up. So we call these kind of like a child cut. And you can see that this is pretty basic. You can develop that using your MSIP and your cut attributes. And then you can subdivide this in. And the great thing about some of the tools that we have in MineSight is we can easily separate this cut into the multiple activities that are happening. So as Mike was talking about units and mineable units, here we have waste. We have a coal seam that's going to be mined as a unit, another waste parting or a separable activity of waste, another coal group or group of seams that's going to be mined as one unit, and a footwall wedge. So we actually have 5 occurrences of activities in a single yellow cut. So one of the tools that we use to split that out is the Mine2, which is a really handy tool. So it looks at the sequential order of seam occurrences, and using the list that's been built up of mineable unit of coal. This is partings, but that's inside this coal seam. Using that logic, bringing it over into here, we can use the Mine2 and show the 5 different activities that are happening with one cut. And the beauty of using that Mine2 logic is you save yourself having to build 5 different cuts. You can take the same cut and change the Mine2 in the right order, and then you can have 5 different little pieces of information you can then use in your MSIP. So it's really handy that Mine2 allows you to not have to build multiple cuts. And then inside of that, we may want to split up along strike length. We may want to split up these cuts, these long slices, into distances, which can represent maybe a week of activity. It could represent a unit of activity in terms of time, or it could represent a minimum mining distance. For example, that slide back where you showed the shovel mining the waste, then the backhoe is pulling down the waste. That can happen right beside each other. So we may want to make sure our slices represent a proper distance apart that needs to be maintained for these sequential activities, so we don't end up having a whole bunch of activity happening in the same area, which is what we want to avoid, because that's not feasible. So what we want to do is, now that we have our cuts and we have our information, we've got all these attributes, we want to start assigning these attributes to these cuts so we have that at our hands available to us as a planner so that we can schedule and optimize a schedule. Perhaps we don't have enough backhoes or dozers available to do the activity, and that could end up being a limiting factor in our schedule. So we want to make sure that we're planning around the right tools and correctly calculating our limiting factors. So what we want to do is start attributing our cuts with the information that we can use, not just shovel and truck hours, but backhoe hours and dozer hours, and the yield, the loss and the dilution, all of that we want to associate with our cuts just for the purposes of generating a better plan. So we can set up use the custom Python scripts, and we can use the scripts to attribute the cuts with a type of recovery or type of mining method, if you want to think about it in that kind of terms. Are you using a dozer? Is he pushing straight down dip of the coal seam? That's a different productivity and a different kind of equipment set than using a backhoe to strip off the waste and then a backhoe to recover the coal. So it allows you to attribute the type of equipment you want to use, and then from that you can kind of track. One of the tools that we're working on getting towards is this advanced scripting, and again, it's just attributing all this information into our cut so we have it on at our hands to use for scheduling beforehand, rather than calculating some of these activities afterwards and finding out this schedule, which got us the right amount of coal and the right types in the right order. We do not have enough dozer power to support this, so we need to bring in extra dozers. If we can't do that, you might not even have a feasible schedule. You don't want to find that out on the back end. You want to have that up front. So we want to attribute this information to our schedule. So for example, some of the loss in the dilution, we want to attribute that so we can correctly calculate delivered ore or delivered coal to the plant and the clean coal, which is our revenue generator, and some of our auxiliary equipment hours, which can often in these complex coal deposits become a scheduling limitator because you don't have enough of them or you get too much activity bunched up into a certain area. So the whole purpose of that is just to attribute that information into the cuts so that we can use it in our SO plans so that we can actually build an optimized and feasible schedule. So, thanks.